We don't know from the question stem how much fuel this fuel tank holds. But I'm going to pretend, I'm going to say that this fuel tank holds 27 liters. And I'll talk at the end of the video about why I'm choosing a number for this specific unknown, why I'm choosing a number for capacity. And I'll talk about why I'm choosing 27. But for now, let's just see what this does to the question. So when n liters of fuel were added to a tank that was already a third full. All right, so before we add anything, we've got this thing is a third full. And if we're pretending that the whole thing holds 27 liters, well, a third of that is 9 liters. So we start with 9 liters. And then, well, when n liters of fuel were added to this, so we start with 9 and we add n. We don't know how much n is, but we add some unknown amount. And then we're told that that brings us to, when n liters of fuel, the tank was filled to 7/9 of its capacity. So after we add that extra fuel, we get to 7/9. And again, if we're pretending the capacity is 27, well, let's think about what 7/9 of that is. 1/9 of 27 is 3. So 7 of those is 7 times 3, or 21. This is nice because, well, now we can figure out what n is. We started at 9, added n, and got to 21. That means n is just the difference. N is 21 minus 9, which is 12. So now we've got a set of numbers that satisfies the question. We now know that with an n of 12 goes with a capacity of 27. So how do we use this to figure out what to click? Well, what's the question asking? The question asks, in terms of n, what is the capacity of the tank? So the question is just asking for the capacity, and we know that with our n of 12, the capacity is 27. So when n is 12, the answer to the question is 27. So all we have to do is go to our answer choices, plug in 12 for n, and see which one or which ones lead to 27. Actually, if you look at the answer choices, we can see that only one of them is going to work. They're all just taking different fractions of n, or in our case, of 12. So those are going to lead to completely different values. So as soon as we find the one that leads to 27, we've got our answer. Another thing to notice in those answer choices is that they're an increasing they're in order of increasing value. A is 10/9 of n, or 10/9 is just a little bit more than 1. B is 4/3, which is 1 1/3 times n. C is 1 1/2 times n. D is over 2. E is even more over 2. So they're in increasing order, and we can use that as we test them. All right, so B, we've got 4/3 of n, or for us, it's 4/3 of 12. I'll just write it as a fraction so we can visualize it more easily. So 4/3 times 12, let's do some canceling. 3 cancels with the 12, which becomes a 4. And so answer choice B, when we plug in our 12, becomes 4 times 4, or 16, which is not our answer, and it's also very clearly too small. So we need to plug in a bigger number for our multiplier here. So B is not the answer. We know A is not the answer as well, because that's a smaller number times n. Let's go to D. D, we've got 9/4 times n, or for us, 9/4 times 12 over 1. And again, we can cancel 4 cancels with the 12, which becomes a 3. And we're left with 9 times 3, or 27, which does match. So D is our answer. And we don't need to test C or E, because we can see right away that they're different fractions times n. So there's really no chance that they're going to lead to the same value. So a pretty efficient way to solve this question. But I want to go back to the very first thing that we did and discuss why we chose for capacity and why we chose this specific number. So at the very beginning of the question, we might have made the decision to go with value substitution. But then there's actually two unknowns, right? We've got the n liters right at the beginning. We didn't know that number. And we didn't know the capacity. So I guess my question is, why did we choose capacity? I mean, I guess we know now that it worked out pretty nicely to go that way, but how did we know beforehand that it would work out? Well, really, it was just from the stem, right? We have all those fractions that are hard to deal with when we're dealing with a variable. So we've got a third full, or a third of the capacity. We've got 7/9 of the capacity, and those fractions would just be much easier to deal with if they were of a number. So that's why I chose to choose for capacity rather than choosing for n, because the relationship between n and those fractions is a little less clear. So I think that's the biggest takeaway from this video, from this method of solving the question. If you're using value substitution, if you're picking numbers, think carefully about, if there's multiple unknowns, well, think carefully about what would be the easiest unknown to work with. And usually that's just a matter of reading the question and thinking lazily, thinking, well, what is going to make my life easiest? Here, those fractions were easier to deal with if we had a number for this unknown rather than for this unknown. And so what else? So why did I choose 27? I mean, we know now that the numbers worked out, but why? How did we know that 27 would be likely to work out? Well, for one thing, I wanted a number that would be easy to work with a third. So I need something that's a multiple of 3, and it would be easy to work with 7/9, which is a multiple of something that's a multiple of 9. And there's obviously 27 isn't the only number that satisfies those conditions, but I chose 27 just because I liked the guideline that if I'm using value substitution in a fraction question, well, it's very often the case that the best, or at least a good number to work with, is the product of the denominators. And that's just because then we're guaranteed to get a number that's easy to work with both fractions. So I chose 27 because it's the same as 3 times 9. And it's not always the case that if you're using value substitution on a fraction question, the best number is the product of the denominators, but it very often is. So that's a good starting place. All right, I think I've talked far too long about this, so I'll leave it at that. But this is a nice method for solving this question. Not the only method, of course, but a good method. And the main thing I want you to remember is that we thought carefully about what would be the best unknown to pick a value for.